Page 313, question number 3. We're asked for the gravitational potential energy relative to the ground when he's at the highest point in the flight. So, our initial velocity is 21 meters per second at an angle of 20 degrees. Our height is 15 meters above the ground to start with. Now, I don't like the fact that we've got an angle in a question with energy, because the whole point of doing an energy type question is the fact that it's scalar, so we don't have to worry about directions. However, in this case, we are going to have to slightly worry about the directions here. The reason being that 21 meters per second, we know the y component will change as they go up into the air. The x component has no acceleration, so there's no change in the x direction. Which means at the top of the motion, we are still going to have that x velocity here. So to calculate that velocity in the x at the top of the flight, it's going to be 21.0 meters per second times the cosine of our angle, 20 degrees. So this is going to be the velocity of the person at the top of the flight, which we are going to have to take into account. So for part A, again, we need to use our law of conservation of energy. So the sum of the mechanical energy at the bottom will equal the sum of mechanical energies at the top. So initially, our person has kinetic energy. So kinetic energy initial plus gravitational energy initial will equal the kinetic energy final plus the gravitational potential energy final at the top. Now in this case, we're looking for that gravitational potential energy at the top. So to figure out our gravitational potential energy at the top, we're going to have to minus EK final to the other side. So we're going to have EK initial plus EG initial minus EK final gives us our gravitational potential energy. So to find our kinetic energy initial, that is going to be the mass multiplied by the initial velocity squared divided by 2, plus our gravitational potential energy, mgh initial, plus our final kinetic energy, which will be mv final squared divided by 2, which gives us our gravitational potential energy final. So substituting in values, we need our mass, which is 56 kilograms. So 56 kilograms times our velocity, 21 meters per second, all squared, divided by 2, plus 56 kilograms times 9.81 meters per second squared, plus times our height, which is starting at 15 meters. We have to subtract our kinetic energy. Sorry, there should be a subtraction up here, which is going to be our mass, 56 kilograms, times our velocity, and we need to use that x velocity, the 21 cos 20, which we need to square and divide by 2 equals our gravitational energy at the end. So grabbing our calculator here, we can see that we need we have 56 times 21 squared divided by 2 plus 56 times 9.81 times 15 meters minus 56 times brackets 21 cos 20 close brackets squared divided by 2, and nope, just a sec, missed a bracket in there. I need to insert close brackets there. There we go. And that will give us a gravitational energy final of 9,684.84 etc. joules. So with significant digits, we get 9.68 times 10 to the power of 3 joules of energy. Going on to part B. So part B tells us the net is 2 meters above the ground. How fast is he traveling when he hits the net? So for part B, we have our initial velocity is 21 meters per second. Our height initial is 15 meters. Our height final will be 2 meters. And we are looking for that final velocity. So again, we're going to start off with the sum of the mechanical energies, at the start is equal to the sum of the mechanical energies at the end. So we're going to have our EK initial plus EG initial equals EK final plus EG final. Now in this case we're looking for that kinetic energy, so I'm going to have to subtract my gravitational potential energy to the other side. So when we do that, we're going to have our kinetic energy initial plus gravitational energy initial minus gravitational energy final equals EK final. So substituting in equations, we're going to have mass times the velocity initial squared divided by 2 plus mgh initial minus mgh final equals EK final. And now we can, now it's going to be mv final squared divided by 2. Now we have mass in all four terms, so again we can cancel mass because we are looking for the velocity. So the second thing we can do is factor out g from this section. So when we do that, our velocity is going to equal brackets h final, h initial, so h initial minus h final. So we take our h initial minus h final. We are factoring out g, so I'm going to put g in front, plus v initial squared divided by 2. Now to get rid of the 2 here, I've got to multiply this whole thing by 2. So I'm going to put it in brackets, multiply it by 2, and to get rid of the square, we have to square root this entire side. So now that we've done that, I'll go up a bit. So to figure out v final, we need to substitute in some numbers. So our final height is 2 meters, our initial height is 15 meters, g is 9.81, our velocity is 21 squared divided by 2, close brackets, multiplied by 2, close brackets, square root the whole thing, and then we can plug that into the calculator to figure out our final velocity. So on our calculator, we want to go the square root of 2 times brackets 21 squared divided by 2 plus 9.81 times brackets 15 minus 2, close brackets, enter, and we get 26.38. So 26.3829, etc. meters per second. So v final is equal to 26.4 meters per second as our final answer.